Chapter 12, Part A, Deflection of Beams and Shafts, Example 2. So in this example, we want to determine the elastic care from load distribution. We have a load function provided by this equation, and we want to determine the elastic care from the load distribution. So EI d to the force y dx to the power of 4 is equal to a negative wx. And that's the equation of the load. So that's negative, it's a downward direction, and that's a w naught sine pi over L times x. If you integrate it for once, it gives you shear, and the first constant appears. If you integrate it for twice, it just gives you the moment. So loads goes to shear, goes to moment, and having the second a constant of integration. And if we call this equation 1 and this equation 2, and apply the boundary condition, so A and 2 gives us C2 is equal to 0, and this time C and 2 gives us C1 times L equal to 0. That says C1 should go 0. In this method, we have 4 constant of integration, so we need 4 boundary condition. So 4 constant of integration goes by 4 boundary condition. It means for each integration constant, we need 1 boundary condition to get the solve the unknown. So if we already know C1 and C2 goes 0, by third integration, we can get a slope from moment, and third constant appears. And at the same time, by the fourth consecutive integration from load, we can get the elastic curve, and that's the last constant, C4. If we call these two equations 3 and 4, applying B and 4, so that's B at x equal to 0, y is equal to 0, B at 4. By replacing x equal to 0 in this equation, we can get C4 that goes by 0, and at the same time, D and 4. This time D, x at the very end is x equal to L, and again we have no upward and downward movement because of the a support at B, and that says C3 is goes 0. So all the constant goes 0. So if we write down the elastic curve equation and rearrange it, it gives us EI times the delta. It's a negative W L to the power of force over pi to the power of 4 sine pi over L x. And at the same time, a slope at A, because it's a simple support, we can have a angle of uh, theta at both ends, and they are identical again to each other due to symmetry. Theta A is equal to theta B, and if you do the math, it gives you a theta A is equal to a negative WL cubed over EI pi cubed. And what else? If you look at the symmetry of the structure, it's obvious that x due to symmetry delta max happen at x equal to L over 2 at its center. So, and if you do the calculation, it gives you this equation. This part is simply sine of pi over 2, which is 1. Sine of 90 degrees, it's a 1. and and if you replace that, it just gives you delta maximum is W naught L to the power of 4 over pi 4 EI. And that's a downward movement for delta maximum. Thank you.